All right, Binit, the floor is yours.
Thank you, Dr. Choi. Okay, good afternoon, everyone. My name is Binit Shrestha from Nepal. I'm a PhD candidate here at UNLV, as you all know. I would like to welcome you all to my PhD dissertation defense. I'm very thankful for everyone for coming to this event. This is a very exciting day for me, 3.5 years of hard work coming to fruition. So it's very nice to see so many people from familiar faces from different avenues of my life, both personal and professional. So I really appreciate it. Today, I'm going to talk about my dissertation work, which is on relationship between standardization critical success factors, CSFs, and project performance. I would like to start with the outline of what I'm going to present today to give you an idea of what I'm going to cover. There's a lot I'm going to cover in a short amount of time, so I will try not to go into excruciating detail on everything, and I'll try to condense it as much as I can. So this is the outline. I'll start with the introduction of the topic and a brief discussion on the literature review, which helped me come up with the problem statement, the research needs, questions, objectives, hypothesis, as well as the research methods that I employed to come up with the results, which I'm going to discuss today. And I'll end my presentation with the contributions from my study. So let me start by saying something that is very common knowledge to us all. Delays in projects are common, and which is very unfortunate. 98% of projects incur cost overruns or delays, according to a McKinsey study. The average cost increase is around 80% of the original value, whereas the average slippage in schedule is 20 months behind schedule. Project costs continue to climb, and this has started to impact the economic viability of projects. On the right-hand side, you can see that different sectors in construction are facing delays in projects, mining, oil and gas, transportation, and other infrastructure projects. Oil and gas sector in particular, which is the sector from which I have collected data for this study, is also experiencing difficulties with delays, as can be seen in both the figures. And this is especially true for the construction industry. The construction industry has failed to improve productivity as well as the overall project performance as compared to its counterparts, especially true for capital projects as well. You can see on the right-hand side, the graph shows the manufacturing industry sector having an increasing trend as well as the total industry, but the construction industry has a downward going trend. Construction projects are well known to be prone to numerous risks and uncertainties, which considerably influences the project performance with regards to cost and schedule. But the downward going trend in construction as compared to its counterparts is quite alarming. It is apparent that we are missing out on opportunities to improve the project performance. So how can we capture these missed opportunities? Well, standardization helps. Other industries such as shipbuilding industry and the manufacturing industry have been known to implement the standardization strategy successfully and have reaped the substantial benefits that accompany this strategy. The aerospace industry is another example of such an industry. Considering this, the pertinent question is, how can capital projects do the same? Well, CII suggested that projects implementing standardization critical success factors can successfully attain better cost performance, predictability, and agility. However, before delving into the critical success factors, which is the main part of this study, let's talk about the standardization first and what it is. So what is facility standardization? I have adopted the definition of standardization from CII, in which they have defined it as the development and use of consistent designs to align project stakeholders, objectives, and scope to capture and optimize schedule, cost, and value. On the right-hand side, you can see different facilities in a gas transmission plant, and you can see the consistent designs that are being used for this facility. So let's dive deeper into facility standardization. There are different levels of implementation of facility standardization. As you will see in this figure here, PIP, there is project level standardization, systems level, package level, and equipment level standardization. Let's see an example of a systems level standardization. This figure shows 7 standard components for a well site configuration in differently colored Legos. You can see that this is a systems level standardization. This is one of the configurations that is possible, components coming together in a standardized facility. I hope this gives you an idea of how facility standardization works. Now let's discuss a real life project as an example of standardization executed successfully in projects. CII conducted a case study related to the benefits of standardization in lower sulfur gasoline facilities. This project was designed once and executed 4 times. And you can see the demonstrated cost and schedule benefits in the table. The benefits include savings of over 55 million, which was nearly 13% of the total installed cost. But wait, benefits of standardization are not just limited to cost and schedule. There are plenty more benefits. Choi et al. Identified 13 such specific benefits, ranging from learning curve benefits in fabrication, operation and maintenance, commissioning and startup, to design once and reuse multiple times, and reuse by relocation of existing assets. However, there are also trade-offs of standardization, and it is equally important to understand these trade-offs for successful implementation of standardization. We can observe that the advantages outweigh the disadvantages, and this is good. Realizing these benefits and understanding the trade-offs can help improve the project performance, as we can see in this following graph. This graph shows 6 performance metrics for a standardized project. This is based on an actual case study conducted by the CII. And we can notice here that the standardized projects and the performance metrics are performing well. They have either met expectations or exceeded expectations, all of the performance metrics. So we can say that the projects perform well with the standardization strategy. But what about different project functions? Let's say engineering. So I'm going to give you an example of engineering cost savings for cost and schedule. This is just one example of one function, engineering, but there are other functions as well, like fabrication, construction, O&M, where these advantages can be seen. So the y-axis represents the percent spent for cost and schedule as compared to customized projects. The x-axis shows the different units, in this case, projects. The differently colored lines represent the different programs on which the case study was conducted. And the dotted line is a representation of a 100% line that is for the conventional customized project cost and for the schedule. So let's talk about the cost savings. We can see that programs 1 through 8 show a constant trend of decreased engineering cost as the number of projects increase. Program 1, represented by the blue line, shows that the project cost for engineering went down from 100% to less than 60%. Similarly, for program 8, the brown line shows that the program cost went down from 100% for engineering to less than 5%. This is because program 8 did not require engineering redesign. And this is awesome because traditional projects spend 100% every time for subsequent projects. For the schedule, we can see a constant trend of schedule decrease, similar to the cost savings, as the number of projects increase. How much each project standardizes can drive additional schedule savings. So far, we have talked about the significant benefits that come along with standardization. But even though the benefits are there for everyone to see, the industry, capital projects in particular, has failed to realize the full benefits of standardization. These are some of the factors that Choi et al. Has identified as a problem on why the industry has failed. Change of leadership, change of project manager, change of project team, scope and design. Different operation and maintenance team are a few examples. Change is the operative word here. Consistency, alignment, and commitment, they're important for successful standardization in projects. So let's do a quick recap of what I have covered, shall we? While there are considerable benefits of standardization, and we have seen from literature that facility standardization helps improve project performance, as well as implementing the critical success factors improves project performance, still standardization is not being implemented at higher levels. construction industry in particular has failed to maximize the standardization benefits. This is why the project performance is still not up to the desired levels. The projects are still expensive and takes long time to complete them. This brings me to the problem for the industry as a whole. Capital projects in the construction industry have failed to improve their project performance and achieve higher levels of facility standardization. Well, to address this industry issue, CII identified 6 solution elements and 5 tools, one of which was introducing 15 standardization critical success factors. So what are critical success factors? Critical success factors, or CSFs, are strategic goals, decisions, or acts that contribute significantly to successful implementation. CII came up not just with the critical success factors, but also their definitions, optimal timings of implementation, as well as the lead parties responsible for implementing these CSFs. For example, CSF1, alignment and approval, is defined as project stakeholders must be aligned vertically and horizontally on the standardization approach and the project drivers. The optimal timing they have defined is from early opportunity framing through late selection, and the lead parties responsible are all parties, owners, contractors, as well as suppliers and vendors. So I'll not go through all the CSFs, but I'll name them. Standardization early identification is another one. Discipline to maintain standardization. Operations and maintenance consideration. Basic engineering design data. Defining the standardization approach as early as possible. Applying knowledge to subsequent projects. Constructability of standardization. Experience and capability of the project team. Benefits and trade-offs recognition. Procurement development. Technology maturity. Recognition of risk of standardization, suppliers and vendors involvement, and feasibility analysis of standardization. It is to be noted that these 15 CSFs are identified and on the basis of the subject matter experts' opinions. It's not based on an actual study. And I want you to remember that for now. Okay, well, besides these 15 CSFs, CII also put forward other solution elements to address the industry problem we discussed, such as standardization business case analysis model, standardization decision-making model, standardization work process and RACI chart, innovative technologies and management approaches for standardization, standardization CSFs, which we have discussed, and a status checking tool for standardization. It's one of the 5 tools that they have put forward. Besides these, here are some of the more studies by Choi et al. On standardization. I'll let you take a quick look. And here are some more. And we move to other literature on success factors. Literature is rife with references on standardization, and these are some of the key literature that highlight the potential factors for standardization, such as owners' involvement, technology, operations, design, collaboration, market, culture, and feasibility. Now that I have talked about the existing literature, let me do a quick recap again. So the existing literature on standardization consists of studies on different solution elements on improving implementation of standardization, other potential factors important for standardization, as well as the critical success factors on standardization. And even though standardization CSFs have been identified by CII, these critical success factors were identified based only on the experience of the subject matter experts and their opinions. So there is a gap in literature, which is that there is no study investigating the relationship between standardization CSFs and project performance based on actual projects. And this is the key. Addressing this gap in literature is important, which brings me to the problem statement for this dissertation study. The industrial sector lacks adequate understanding of relationships between critical success factors that contribute to higher facility standardization and project performance. This brings me to the research needs, and there are 3. First, the industry needs to understand the current industry status of CSS CSFs accomplishments based on both degree of accomplishment and timing of accomplishment. Second, there is a need to understand how standardization CSFs accomplishments are related to better project performance. Industry needs to understand how accomplishing more CSFs impacts the project performance. If industry knows accomplishing more CSFs improves project performance, they will try to accomplish more CSFs. And finally, there is a need to understand if there exists a combinatorial impact of standardization CSFs on project performance. Construction projects are complex. Combination of CSFs may have a high impact on project performance, and we need to understand that. These are the research questions which I came up with for this study. First, what are the current industry status of CSF's accomplishments? Second, how are standardization CSF's accomplishments and project performance related? And third, are there combinatorial effects of CSFs on project performance? The following are the research objectives of the study. Task 1 is to examine the current industry status of CSF's accomplishments for both degree and timing of accomplishment. Task 2 is to examine how more accomplishments of CSFs affects project performance. And task 3 is to examine the combined effect of CSFs accomplishments on project performance. There are two research hypotheses that I have developed for my study. The first one relates to the correlation between CSF accomplishments and the project performance. The null hypothesis for this one states that there is no relationship between standardization CSF accomplishment in bundle and cost effectiveness performance and schedule performance for capital projects. The second hypothesis is for the combinatorial effects of CSFs on project performance. This null hypothesis states that there is no collective and interactive or combinatorial effects of standardization CSF accomplishments on cost effectiveness performance and schedule performance again for capital projects. As with all research study, my study has also a defined scope and certain limitations. For example, this study is limited to the upstream, midstream, and mining sector. These are some of the examples of projects involved in the upstream, midstream mining or UMM sector. Pipeline compressor stations, gas transmissions, natural gas pipeline, natural gas processing, and natural gas liquids projects. Another limitation is that I have only considered standardized projects or programs. Non-standardized projects or programs that did not implement the standardization strategy are not part of the collected data. Therefore, I make no comparisons between standardized versus non-standardized projects. Another limitation is that I've only considered the cost and schedule performance metrics. Definitely, this study would benefit from addition of more performance metrics. Another limitation is the timing of data collection. I collected data from 2017, 2018. Things might change, new projects completed, so definitely inclusion of those projects is also beneficial. And finally, the sources of data is another limitations. I have to say that the findings of this study may be positively skewed towards facility standardization. This is because data collected is mainly from globally leading companies that have more knowledge and more experience and a better team frankly, that have been implementing the facility standardization strategy. As a result, the levels of facility standardization or the CSF's accomplishments or even the project performance are expected to be higher than those that for not leading companies in this field. Okay, before we move on to the research methods, here are some of the key definitions of some key terms that I will be using in the upcoming sections. For example, program, I have defined as a collection of standardized projects. So project is one individual facility or a site, in this case, which has been executed with the standardized strategy. Percent standardization is the summation of the total installation cost of standardized components, divided by the total installation cost of the project. Please take a look at the rest of the terms briefly. I will be discussing most of these terms in the upcoming sections anyway. However, if we have to, we can come back to this if and when needed. All right, so let's start with the research flowchart. I conducted comprehensive literature review, which helped me come up with the research problem and an approach, after which I designed the interview questionnaire, conducted the interview, and then analyzed the data for the results, which I'm going to discuss today. I've used it for my PhD dissertation. I have been using it and will use in the future for future journal papers as well. So let's start with the interview design, which is the most, I guess, one of the most important parts of data collection for this study. So I developed this interview questionnaire by reviewing previous interview questionnaires from various sources, benchmarking questionnaires, as well as conducting literature review, which helped me identify the relevant factors and questions to develop this questionnaire. While designing the interview questionnaire, it was important for me to consider some crucial points to make the interview questionnaire as effective as possible, such as asking to the point and pertinent questions, proofreading the questionnaire, making sure not to make it as too long, providing necessary instructions, which is always necessary, and keeping in mind the target audience when I was designing the questionnaire. After finalizing the interview questionnaire, I conducted the interview, but while finalizing, I made sure that I asked pertinent questions, removed any sort of ambiguities, removed any unnecessary questions, and most importantly, made it as effective as possible. Then I conducted the interview with the subject matter experts starting in September of 2018 and completing the interview questionnaire data collection by December of 2018. I employed two methods to conduct the interview, a face-to-face interview and telephone interview, depending on the availability as well as the convenience of the potential interviewees. So here are some examples of the interview questionnaire. This is the first page, which includes the basic information about the interviewees and basic information about the standardization program. The second section deals with the standardization projects with different functions and related costs and schedule, as well as performance metrics. And this one in particular is about the standardization critical success factors and the degrees of accomplishments in the projects. So moving on to data collection. So I employed non-probability sampling method, did not use random sampling because firstly, the scarcity of standardized projects, which I have discussed previously. This makes the data collected of high value, and sometimes the companies are not willing to share information because of the standardization strategy, because it has value. Also, because of the limited subject matter experts in this field, as well as the lack of resources in terms of time and workforce. Talking about data collection, I collected data from the following three sources: CII research team, which I was also a part of, CII UMM community members, upstream midstream mining community members, and CII modularization community for business advancement. So I contacted more than 150 experts, out of which 11 responded, and I actually conducted interviews with 8 of them. So I collected 8 programs from 8 interviews, which included 43 projects. So let's take a look at some of the data characteristics of the collected data. We can see the UMM sector is well represented here. The participants are all very experienced in their field. Level of standardization is dominated by project level standardization. And there are 6 owners and 2 contractors representing the collected data. The present standardization maximum was 95% with an average of 70%. Business drivers was dominated by cost and schedule. And for the primary factor for the programs was a more balanced approach between cost and schedule. Now let's talk about the research methods corresponding to the research objectives. There are 3 methods, and I'll discuss each one in detail. But just to give you a quick idea, task 1 was the status of accomplishment analysis, which is more of a descriptive sort of analysis. Task 2 is a correlation analysis, more of a quantitative analysis. And task 3 is a qualitative comparative analysis. I write qualitative analysis, but it is not exactly a qualitative method, and you will know, understand this better when I get to this section later. And I'm now going to start with the status of CSF accomplishment analysis. Here, I wanted to understand the CSFs that were accomplished more commonly, CSFs that were difficult to accomplish, the CSFs that were commonly accomplished on time, and the CSFs that were not accomplished on time. To do this, I investigated the degree of CSF accomplishment, which I have defined as the percentage values of sample projects with mostly or fully accomplished CSFs. To do this, it was measured on a 5-point Likert scale: not accomplished, partially accomplished, half accomplished, mostly accomplished, and fully accomplished. I also investigated the timing of accomplishment, which I have defined as the percentage values of sample projects which were accomplished early or on time. This is an example of the timing of accomplishment graph for CSF8, constructibility of standardization. The intent of having this graph here is to explain how the graph is to be read. So the x-axis represents the number of projects. The y-axis represents the different phases in a project. We can see the number of projects involved in this analysis, as well as a legend on the side to explain how the graph is to be read. So this portion here, this section, which is lightly shaded in a diagonal manner, represents the recommended timings by the CII for accomplishing CSF8. In this case, it is the assessment phase and the selection phase, as you can see in the x-axis. The black shaded portion represents the phase that comes after the recommended timing, which is the late phase. Here, it's from basic design to operation and maintenance. And the lightly shaded portion here represents the phase that comes before the recommended timing, which is the opportunity framing in this case. These gray bars or columns, they represent the number of projects that fall under each phase: late, on time, or early. So here in the early phase, we can see there are around 6 projects that were accomplished earlier than the recommended timing. And there are around 19 projects that were represented, that were accomplished later than the recommended timings, and therefore fall under the black shaded area. The second task was the correlation analysis, in which I wanted to understand the relationship between the accomplishment of standardization CSFs in bundle and project performance. The data type was ordinal, which led me to conduct non-parametric tests, and therefore I selected a Spearman's rank correlation analysis to do this, to complete this task. So Spearman's correlation analysis provides a Spearman's rho coefficient, which allows for the interpretation of the relationship between the variables. It gives the magnitude of the relationship and the strength between the variables. The third task and the final task is the qualitative comparative analysis, QCA in short, which I employed to examine the combinatorial effects of CSF accomplishments on project performance. So let's first understand what the QCA method is. QCA is a configurational research approach, in that it is an analytical method for comparison between cases that allows for an investigation of multiple causal configurations and is based on both theory and knowledge. To elaborate, it helps understand the interactions between outcome conditions and conditions, which are also called multiple causal configurations. So the beauty of the QCA is that it not only allows for generalization, which is the staple of a quantitative analysis, but also allows to make causal links, which is the staple of a qualitative analysis, thereby allowing the researcher to examine the similarities and differences between the cases. You can see in this figure on the bottom right corner how the qualitative comparative analysis falls somewhere between a statistical analysis and a case study analysis. Therefore, it fills in the gap and provides a balance between a large N sample population or statistical analysis and a smaller sample population analysis. Now that I have talked about what the QCA is and its characteristics, let's talk about the QCA steps. There are 6 steps, as you can see here, and I will discuss each step in detail, starting with step number 1, variant and cases selection. So I selected the crisp set variant, also called CSQCA, for this study. It is the most popular variant, but I did not choose CSQCA because it's the most popular one. I selected it because for the profile of the data I had, CSQCA variant was the best fit. So what is CSQCA? So CSQCA follows Boolean algebra, provides a distinction of 1 and 0, 1 being full membership and 0 being non-membership, so a binary distinction. So for CSQCA, allowed for this dichotomization, which I'm talking about, the binary distinction, for all the 15 CSFs for the data that I had. There was no loss of information or data richness, and all the selection criteria were fulfilled. So what are these selection criteria, you ask? These are the selection criteria. First was to have a balanced presence of both positive and negative cases. Criteria number 2 was to have no counterintuitive in configurations as much as possible. Criteria number 3 was to have a presence of cross-section diversity in the data. And criteria number 4 was to have a presence of adequate variation for each condition. All these criteria was fulfilled by CSQCA, but not by the other variants. This is why I selected the CSQCA variant for my study. Step 2 was the selection of causal outcomes and causal conditions, more of a definition. So the causal conditions are CSF accomplishments in projects, which is the independent variable. It was measured on a 5-point Likert scale, and I provided a numerical value for each Likert scale, as you can see. And for the values 3 and above, I assigned full membership, which means that the CSFs were accomplished. And for values 1 and 2, I assigned non-membership, which means that the CSFs were not accomplished. Similarly, for the causal outcomes, which is the project performance and the dependent variable here, it was also measured on a 5-point Likert scale. And similar to CSF accomplishment, I provided a numerical value for each Likert scale. And to the condition, I provided a value of full membership for values 3 and above, which means that the projects were a success in terms of performance. And values of 1 and 2 were assigned non-membership, which means that the projects were not a success in terms of performance. Step 3 was the selection of causal conditions. So literature has defined certain strategies that are necessary for the selection of causal conditions. If the CSFs did not fulfill these strategies, I removed those CSFs from the analysis. So let me discuss each strategy one by one. First, I removed CSFs from the set if the CSF was accomplished by all the projects, or if just 1 or 2 projects failed to accomplish those CSFs. This was mainly to provide variation in the data for the analysis. So based on this strategy, I removed CSF 1, 2, 5, 9, and 12. Second, I removed CSFs from the set if there were 3 or more data points missing. This is fairly straightforward, and from this strategy, I removed CSF 11. And finally, I removed CSFs from the set if they did not display considerable relevance to cost and schedule based on existing theory and knowledge. The remaining CSFs all showed relevance. That is why I did not remove any other CSFs from the analysis. So these are the CSFs that qualified based on the selection criteria. However, I have to say that the other CSFs that were not included in the analysis are equally important. It's not like they are not important. They all should be considered for successful standardization implementation. You remember the reasons I removed them were primarily because either they were all already accomplished at a high level or because they had some missing data points, not that they lacked relevance. The fourth step is generating a raw data table, also called a truth table. So a truth table is essentially a summary table that sorts the collected data into binary form, into different combinations of values on causal conditions, also called configurations here, as you can see on the left column. This table identifies the causal patterns of sufficiency, which means that the combinations of conditions are sufficient for the outcome. Each logical combination of values on the causal condition is represented as a row, as you can see in this table. Every row in the table represents a different configuration of different conditions that produce a particular outcome. Talking about outcome, on the right-hand side in the column, you can see outcome is also assigned a value of 1 and 0 based on the scores of the cases which share the combination of the input value. This is all done by software, mind you. Next, we also have a number of cases column, which shows how many empirical cases show a particular configuration. Then a truth table is generated after we set consistency threshold. So what is a consistency? Consistency replicates the notion of significance level in statistical analysis. So I removed configurations and cases that did not meet the consistency threshold. This is a similar table for schedule, truth table. You can see the different configurations, different conditions, number of cases, and outcomes. The final two steps are analyzing the necessary conditions and the sufficient conditions. So these are the two analyses for QCA. So let's start with the necessary condition. So what necessary condition is defined as the measure to the degree to which the outcome is the subset of the causal condition. You can see condition A and outcome Y in this figure. So this causal necessity says that the occurrence of the outcome Y in this figure here, for example, is not possible without the presence of condition A, but A alone is not enough to produce the outcome Y. All cases in which outcome Y occurs share the condition A. So outcome Y is the subset of condition A, which means that in each case, the degree of membership in outcome Y is less than or equal to the degree of membership in condition A. So for consistency score for necessary condition, I selected a value of 0.9, which is recommended by the literature. Causal sufficiency, on the other hand, is quite the opposite of causal necessity and is defined as the measure of the degree to which each causal condition is the subset of the outcome here. So condition A in this figure is sufficient to produce outcome Y if Y will always occur if A is present. But other conditions besides A may also produce the outcome Y. Logically, this means that all the cases where A is present share the outcome Y, which means that across all the cases, the degree of membership in the condition here is consistently less than or equal to the membership in outcome Y. So causal sufficiency has two types of solution, intermediate and parsimonious for my analysis. And for consistency threshold, I selected a value of 0.8, which is also, again, recommended by the literature for sufficient condition. I use the FSQCA software version 3.0, which uses the Quinn-McCluskey algorithm. Here are some of the snapshots of the tool being used. So a quick recap of the key studies and areas of interest before we move on to the results. So the key areas of studies are status of accomplishment analysis, correlation analysis, and combinatorial analysis. Areas of interest for status of accomplishment analysis is degree of CSF accomplishment and timing of CSF accomplishment. For correlation, the areas of interest are project performance scores and degree of CSF accomplishment scores. And that's the same for the combinatorial analysis as well. So let's start with the results for task one. And I want to start with the degree of accomplishment analysis. In this graph, you can see that there are quite a few CSFs which have higher levels of accomplishment. Most noticeably, CSF 5, Basic Engineering Design Data, CSF 9, Experience and Capability of Project Team, and CSF 12, Technology Maturity. But I want to focus on the ones that have lower accomplishment. CSF 8, Constructability of Standardization, and CSF 15, Feasibility of Analysis of Standardization. Based on the analysis of the actual projects being implemented with the standardization strategy, these two CSFs are not being accomplished at a higher level. And the industry needs to focus on accomplishing these CSFs more. For timing of accomplishment, I have selected these four figures. We can see CSF1 alignment and approval and CSF2 standardization early identification have quite a few projects which are being accomplished late. Mostly these are the responsibility of the owners and should be accomplished early on as provided in the definition. Also, we have benefits and trade-offs recognition and CSF 15 feasibility analysis of standardization, which are not being accomplished at a timely fashion, in a timely manner. So in conclusion, the industry needs to pay attention to CSF 8 and 15 because their degree of accomplishment from actual projects analysis is quite low. And for timing, CSF 1, 2, 7, applied knowledge, 10, and 15 are not being accomplished in the recommended timings, and the industry needs to pay attention and put extra effort in accomplishing these CSFs in a timely fashion. Moving on to task 2, which is the correlation analysis. And with this graph and the data table, we can see that there is a statistically positive correlation between accomplishment of standardization CSFs in projects with project cost effectiveness performance. So this means that the projects that are accomplishing more standardization CSFs in general, in bundle, tend to have better cost performance. The Spearman's rho coefficient is 0.465, which shows that the strength of the association between these two variables is rather large and strong. Similar to the cost analysis, the correlation analysis for schedule also shows a positive correlation between accomplishment of standardization CSFs in projects and schedule performance. This means that the projects that have accomplished more standardization CSFs lean towards having a better schedule performance, and vice versa. The Spearman's rho coefficient is 0.700, which again displays a strong relationship, strength between the two variables in question. So in conclusion, we can say that the projects that accomplish more standardization CSFs tend to have better project performance. Now, moving on to the final task, which is the QCA analysis, and the first solution, which is the necessity analysis. So these are the CSFs that are necessary conditions for cost and schedule success. The consistency score I used, if you remember, was 0.9. So anything less than 0.9 is considered to be inconsistent in this analysis. For schedule, we noticed that CSF 10 is an additionally important or necessary condition for schedule as compared to cost. So let's talk about these CSFs, 3, 4, and 6. So we remember from the status of accomplishment analysis that these CSFs were all highly accomplished, or more or less, but there was still room for improvement on the accomplishment status of these CSFs in actual projects. Applied knowledge, CSF 7, we remember, has a very low level of accomplishment in the industry, and the practitioners need to pay attention to accomplishing this CSF because it is a necessary condition for cost and schedule success. Applied knowledge is very important for future projects. Consistent lessons learned documentation and applied knowledge should be implemented for subsequent projects to improve the chances of cost and schedule success. CSF 10, benefits and trade-offs recognition, is an additional necessary condition for schedule success. And if we remember from the status of accomplishment analysis, the status of accomplishment for this one from actual projects was also very low. But from this QC analysis, we can see that it is a necessary condition for schedule success. So moving on to the next analysis, which is the sufficiency analysis from the QCA. So sufficiency analysis has actually 3 types of solution, but I have only included 2, parsimonious solution and intermediate solution. So let's start with what the parsimonious solution is. Well, as the name suggests, it is the most simplest form of the solution. It's the solution that reduces the causal recipes or the outcomes, in this case, to the simplest number of conditions possible. It only contains prime implicants. So prime implicants are the conditions that cannot be left out of the analysis in the truth table. So these are the elements of the analysis, as you can see. We have CSF solutions, raw coverage, unique coverage, consistency, which again represents significance level in statistical analysis, and we have solution coverage and solution consistency. So solution coverage and solution consistency are the ones we are more concerned with. Unlike consistency, the fact that the configuration coverage is low does not imply less relevance. In cases where a result occurs because of multiple causal configurations, which is a characteristic of the QCA analysis, a single configuration can have low coverage, but nevertheless be useful to explain a set of results or outcomes. So for the cost effectiveness analysis, we see that a combination of CSF 13 and CSF 14 is a sufficient condition to help improve cost performance. Also, CSF 3, 4, and 6 are sufficient for cost success. For schedule, we see that CSF 13 is a sufficient condition to help with the schedule performance, to improve schedule performance. Next is the intermediate solution, which is a solution that includes selected simplifying assumptions. So simplifying assumptions are assumptions that are driven by theory. And as a researcher, I can select which conditions to include in the analysis and which not to include in the analysis for the outcome. So it's the standard analysis. It's the standard analysis for a QCA method. It lies somewhere between a parsimonious solution, which is the base simplest solution, and a complex solution, which is usually not included in a QCA analysis. Again, we have the same solution elements for intermediate solution as well as with the parsimonious solution. So let's discuss these two for cost and schedule, because they have the most number of conditions for a configuration. So CSF 3, 4, 6, 7, 13, and 14, a combination of these CSFs is sufficient for schedule cost success. And intermediate solution for schedule performance shows that a combination of CSF 3, 4, 6, 7, 8, 10, and 13, if implemented and achieved successfully, helps with schedule success in projects. So I have compiled the results in a nice little Venn diagram here, complete with a list of the CSF names. So for cost success, CSF 3, 4, 6, 7, 13, and 14 are sufficient conditions, while for schedule success, combination of CSF 3, 4, 6, 7, 8, 10, and 13 are sufficient conditions. So we can say that projects that accomplish certain combinations of CSFs tend to have better project performance. So to summarize the analysis of this study, CSF 8 and CSF 15 are the least accomplished CSFs, and CSF 1, 2, 7, 10, and 15 are not accomplished in a timely recommended fashion. So these CSFs are the ones that the industry needs to pay attention in accomplishing more and in a timely manner. Also, the projects that accomplish more CSFs in bundle in general tend to have better project performance, and projects that accomplish certain combinations of CSFs also tend to have better project performance, as evidenced by the QCA analysis. Based on the results, I have the following 4 recommendations to the industry. First, industry needs to accomplish CSF 8 and 15 more, because their accomplishment is less based on the status of accomplishment analysis. Recommendation number 2 is that the industry needs to accomplish CSF 1, 2, 7, 10, and 15 early and in a timely fashion. Also recommend the industry to focus on accomplishing CSFs in bundle more for improved project performance based on the correlation analysis. And based on the QCA analysis, the industry needs to focus on accomplishing these combinations of CSFs to help them achieve improved cost and schedule performance. So I have the following contributions to the industry. So this study helps the industry better understand the CSFs so that the industry can focus on accomplishing least accomplished as well as the most delayed CSFs, and also focus on implementing CSFs that have a higher impact on project performance, both in general as well as a combination. This study also helps the industry thereby execute more standardization CSFs in an appropriate manner. And finally, it helps the industry achieve improved performance in projects because of the previously mentioned contributions. The following are the contributions to the body of knowledge of this study. This study identifies the status of accomplishment of standardization CSFs in capital projects. Also, this study identifies the relationship between standardization CSF accomplishments and the project performance, and how accomplishing one helps the other improve better. And finally, it helps understand the combinations of critical CSFs that are necessary as well as sufficient for project success. I have the following future research recommendations: exploring other industries or sectors such as transportation and infrastructure, commercial. Also, investigating other performance metrics such as quality, safety, or sustainability could definitely add value. Examining advanced work packaging as a supplement or even a complement to standardization strategy can help understand the standardization strategy and what needs to be done to achieve higher levels of standardization in projects. Also, use of advanced technologies such as BIM and AI-driven standardization can help achieve higher levels of facility standardization. And finally, future research could be comparing and contrasting conventional projects with the standardized projects to better understand the CSFs for standardization and how it impacts project performance. I would like to acknowledge the Construction Industry Institute as well as the participants of the interview questionnaire who devoted their time and effort to help me complete this study. These are the list of few of my publications. I have so far published 10 journal papers. One is under review, and there are a few more in progress. I have 6 conference papers. One has been recently accepted. Besides that, I have a few reports and tools where I have contributed as well. And I've also participated in 4 proposals preparations with Dr. Choi, and currently I have a number of citations in Google Scholar of 70. Thank you everyone for listening and being patient with my presentation. And if you have questions, I would be glad to answer them now.